everyone. In the previous lecture we have seen Carnot cycle, and in today's lecture we will see in detail second law of thermodynamics. The branch of thermodynamics started as a discipline to find ways for better efficiency of heat engines and interconversion of work and heat energy. We are interested in a device to convert heat into work by means of series of processes, by means of which such conversion may continue indefinitely without any change in the state of the system. So, we just want to construct an engine which converts heat into work. So, the essential ingredients of a heat engine are source of heat, that is a reservoir, second one is a sink, and third one is a working substance. And heat engine absorbs heat energy at a higher temperature and delivers work and rejects heat energy at a lower temperature. And the thermal efficiency of a heat engine is given by equation which we have already seen in the Carnot engine. Efficiency is equal to work output divided by heat input. Whereas we want to construct an engine which converts 100% heat into work, but it's impossible. So, in today's lecture, we will see the statements of heat converting into a work by using second law of thermodynamics. So, for better working of the heat engine, we want the efficiency heater to be as close to 1 as possible. That means work output divided by heat input is equal to 1. We want this, but it's impossible. And however, there is no engine has even been developed which absorbs heat and delivers work without the rejection of heat at some lower temperature. And this experimental observation constitutes one form of the second law of thermodynamics. So, we will discuss the Kelvin-Planck and Clausius statements of the second laws. So, we will see first why there is a second law of thermodynamics. A process cannot happen unless it satisfies both the first and second law of thermodynamics. The first law which defines about the quantity of energy, while the second law defines the direction which the process can take place and its quality. There are two statements defining the second law of thermodynamics. First one is a Kelvin-Planck statement of second law, and next one is Clausius statement of second law. So, why there is a second law? The first law of thermodynamics does not give idea or information about the change of state or the process, and is this process is feasible or not. So, there is a second law is developed, and it is the second law of thermodynamics which provides the criterion as to the probability of various processes. So, our second law of thermodynamics, here the second law of thermodynamics gives much more idea about the thermodynamic processes, and the law may be defined as heat cannot flow itself from colder body to a hotter body. That means always heat is transferred from hotter body to the lower temperature containing body. So, this is our definition of second law. Heat cannot flow itself from colder body to a hotter body. And the second law is also used to determine the theoretical limits for the performance of mostly used engineering systems like heat engines and heat pumps. Now, the first statement is Kelvin-Planck statement. The Kelvin-Planck statement is, there is no process is possible whose sure result is the absorption of heat and the complete conversion of this heat into work. Means there is no any process is possible which gives 100% result or 100% heat is converted into the 100% work. So such a type of heat engine is not there. And this is the new statement again here, which is stated as, it is impossible to for any device as a heat engine that operates on a cycle to receive heat from a single reservoir and produce net amount of work. And this statement means that only part of total heat is absorbed by heat engine from a higher temperature, and this is converted to work. The remaining heat must be rejected at a low temperature. That means suppose we have provided 100% heat to the system, only required amount of heat or the few percentage of the that heat is converted into work, and the remaining heat must be rejected to a lower temperature region. This is the Kelvin-Planck statement. And what Kelvin-Planck statement says, that the efficiency eta is always less than 1. That means work output divided by heat input is always less than 1. And it may be noticed that even if there is a 100% conversion of heat into work, it would not violate the first law of thermodynamics. And if a heat engine were operated in the reverse order, extracting heat energy at a lower temperature reservoir and rejecting a larger quantity of heat at a higher temperature reservoir by doing work on the system, such a device is called a refrigerator. That means heat is extracted from a lower temperature region and it can be transferred toward the higher temperature region. Only the reverse condition is observed in case of the refrigerator, and in this case second law is violated. And the heat engine as shown in this figure, see, this is the heat engine. Here heat source is T1 and here is the sink T2. In this figure 1 is converting 100% heat into the 100% work. So see, in this condition Q is equal to 100, Q is heat and W is equal to 100 kilojoule. That means 100% work is 100% heat is converted into 100% work. And in second case, see, we have provided 100% heat or 100 kilojoule heat to the system or to the heat engine. Only 40% heat is required for conversion into work, and remaining Q2, that is 60 kilojoule heat, is transferred to the reservoir at a lower temperature. And this system is not satisfying second law, so this statement can also expressed as no heat engine has 100% of thermal efficiency. So in first case, as we want 100% heat is converted into 100% work, but this is not possible. When we have provided 100 kilojoule heat to the system, only 40 kilojoule heat is converted into work, which is equal to 40 kilojoule, and remaining 60 kilojoule heat is transferred to the lower temperature region. This is the actual condition. That's why there is a no heat engine which can convert 100% heat into the 100% work. Now, the next statement is Clausius statement. And Clausius statement is, no process is possible whose sure result is the transfer of heat from a cold body to a hotter body. only hotter body to a lower temperature body, there is heat transfer, and we cannot transfer heat from colder body to a higher temperature containing body. So, Clausius statement of the second law is as below. It is possible to construct a device as a heat pump that operates in the cycle and produces no effect other than the transfer of heat from lower temperature to higher temperature body. And this statement means that heat cannot flow from colder body to hotter body without any work input. See, in this diagram, this is an example of a heat pump, and Clausius statement is based on the heat pump. So, for the first condition, here heat source is T1, here heat sink is T2. Source is always higher temperature region, and T2, that is sink, is the lower temperature region. We cannot transfer heat from lower temperature to the higher temperature region when there is no external work is applied. So, Q1 is equal to 100 kilojoule and Q2 is equal to 100 kilojoule. And in this case, when T1 is here and T2 is here, and when we have applied an external force or the external work is done on the system, suppose work done is 40 kilojoule and heat is Q2, that means initially here is the 100 kilojoule heat, but this heat get transferred due to the applying the force on the system or the work on the system, and this heat is get transferred to the higher temperature region. That means we can say that whenever we can apply the force, there is no work done on the system or there is no heat transfer. And when we apply the force on the system, obviously there is work done, and due to that force we can transfer the heat from lower region to the higher temperature region. And the statement based on this diagram, we can say that heat cannot itself flow from a colder body to a hotter body. Now, comparison of these two statements, Kelvin-Planck statement and Clausius statement. Kelvin-Planck statement is useful for heat engine and Clausius statement is useful for pump or the refrigerator. And Kelvin-Planck statement, it is a negative statement, and the Clausius statement is also a negative statement. And Kelvin-Planck statement is based on the experimental observation and there is no mathematical proof. And Clausius statement is based on the experimental observation and obviously there is no mathematical proof. So this is the comparison between Kelvin-Planck statement and the Clausius statement. So, a heat engine is a device which converts heat or thermal energy to a mechanical energy while operating in a cycle manner. So, TH is the hotter temperature region where heat at a higher temperature region, and TL means the lower temperature, and QL is the heat at lower region. And net work done is equal to W net is equal to QH minus QL, means heat at a higher temperature region minus heat at a lower temperature region. And thermal efficiency eta is defined as W net or the work output divided by heat input, that is W net divided by QH, which is equal to QH minus QL divided by QH. So we can write this equation as 1 minus QL divided by QH. So this is the statement of efficiency. And this diagram shows that it is impossible to build a heat engine with 100% efficiency. and the heat pump and refrigerators are the examples of the Clausius statements. A heat pump is defined as a device which transfers heat from a low temperature source to a higher temperature one. An example, heat pump is used to extract energy from outside cold outdoor air into the warm indoors. And a refrigerator performs the same function. The difference between the two is in the type of heat transfer that needs to be optimized. Means heat is transferred from lower temperature region to the higher temperature region. When apply the force on the system, the heat can be transferred from lower region to the higher temperature region, and here the second law is violated. And heat pumps and refrigerators, here we can find out efficiencies also. And for a heat pump, the efficiency is calculated by using equation 1 divided by 1 minus QL upon QH. And for a refrigerator, efficiency is calculated by using 1 divided by QH divided by QL minus 1. And again the Clausius statement, this is a second expression of a second law of thermodynamics, and there is a, we cannot construct a device which operates in a cycle manner and produces no effect rather than the transfer of heat from a lower temperature body to a higher temperature body. In the new words, we can say that heat cannot be transferred from low temperature to a higher temperature unless extra work is applied. Therefore, it is impossible to build a heat pump or a refrigerator which can work without a work input. So, this system is impossible to prepare, or we cannot prepare such type of engine which can supply energy from lower temperature region to the hotter temperature region. And heat engine is a device which, working in a cycle, convert energy in the form of heat into work. Heat engines converts heat to a work. And there are several types of heat engines, but they are characterized by using the various factors. Among this, the following factors are: they all receive heat from a higher temperature source, that means oil furnace, nuclear reactors, etc. They convert part of this heat into work. They reject the remaining waste heat to a lower temperature sink, and they operate in a cycle. That means heat engines works in a cycle manner. They can extract heat from hotter region and rejects it into the lower temperature containing sink. They convert heat to a work. There is no transfer of 100% heat into 100% work. And initially they can receive heat from a higher temperature source like furnace and the nuclear reactor. So this is all about the revision of second law.